The next topic we need to talk about is a very misunderstood concept in JavaScript, and that is hoisting. So we learned that an execution context always contains three parts: a variable environment, the scope chain in the current context, and the this keyword. We already learned about the scope chain, and so now it's time to take a closer look at the variable environment, and in particular at how variables are actually created in JavaScript. So in JavaScript, we have a mechanism called hoisting, and hoisting basically makes some types of variables accessible, or let's say usable, in the code before they are actually declared in the code. Now, many people simply define hoisting by saying that variables are magically lifted or moved to the top of their scope. For example, to the top of a function. And that is actually what hoisting looks like on the surface. But behind the scenes, that's in fact not what happens. Instead, behind the scenes, the code is basically scanned for variable declarations before it is executed. So this happens during the so-called creation phase of the execution context that we talked about before. Then, for each variable that is found in the code, a new property is created in the variable environment object. And that's how hoisting really works. Now, hoisting does not work the same for all variable types. And so let's analyze the way hoisting works for function declarations, variables defined with var, variables defined with let or const, and function expressions, and also arrow functions. So function declarations are actually hoisted, and the initial value in the variable environment is set to the actual function. So in practice, what this means is that we can use function declarations before they are actually declared in the code. Again, because they are stored in the variable environment object even before the code starts executing. And I actually told you before that function declarations work this way, but now you understand why. It is because of hoisting. And just to make this table a bit more complete, so that it serves as a nice overview for you, I also show here that function declarations are block scoped, as we learned before. Just keep in mind that this is only true for strict mode. So if you're using sloppy mode, which you shouldn't, then functions are function scoped. Next, variables declared with var are also hoisted, but hoisting works in a different way here. So unlike functions, when we try to access a var variable before it's declared in the code, we don't get the declared value, but we get undefined. And this is a really weird behavior for beginners. You might expect that you simply get an error when using a variable before declaring it, or to get the actual value, but not to get undefined. Because getting undefined is just really weird, and it's not really useful either, right? And actually, this behavior is a common source of bugs in JavaScript. So this is one of the main reasons why in modern JavaScript we almost never use var. Now, on the other hand, let and const variables are not hoisted. I mean, technically they are actually hoisted, but their value is basically set to uninitialized. So there is no value to work with at all. And so in practice, it is as if hoisting was not happening at all. Instead, we say that these variables are placed in a so-called temporal dead zone, or TDZ, which makes it so that we can't access the variables between the beginning of the scope and the place where the variables are declared. So as a consequence, if we attempt to use a let or const variable before it's declared, we get an error. Also, keep in mind that let and const are block scoped, so they exist only in the block in which they were created. And all these factors together is basically the reason why let and const were first introduced into the language, and why we use them now instead of var in modern JavaScript. Okay, but now what about function expressions and arrow functions? How does hoisting work for these? Well, it depends if they were created using var or const or let. Because keep in mind that these functions are simply variables, and so they behave the exact same way as variables in regard to hoisting. This means that a function expression or arrow function created with var is hoisted to undefined, but if created with let or const, it's not usable before it's declared in the code because of the temporal dead zone. So again, just like normal variables, right? And this is actually the reason why I told you earlier that we cannot use function expressions before we write them in the code, unlike function declarations. Okay, but now before finishing, let's take a more detailed look at this mysterious temporal dead zone. So in this example code, we're gonna look at the job variable. It is a const, so it's scoped only to this if block, and it's gonna be accessible starting from the line where it's defined. Why? Well, because there is this temporal dead zone for the job variable. It's basically the region of the scope in which the variable is defined, but can't be used in any way. So it is as if the variable didn't even exist. Now, if we still tried to access the variable while in the TDZ, like we actually do in the first line of this if block, then we get a reference error telling us that we can't access job before initialization. So exactly as we learned in the last slide, right? However, if we tried to access a variable that was actually never even created, like in the last line here where we want to log x, then we get a different error message saying that x is not defined at all. What this means is that job is, in fact, in the temporal dead zone where it is still initialized, but the engine knows that it will eventually be initialized because it already read the code before and set the job variable in the variable environment to uninitialized. Then, when the execution reaches the line where the variable is declared, it is removed from the temporal dead zone and it's then safe to use. So, to recap, basically each and every let and const variable get their own temporal dead zone that starts at the beginning of the scope until the line where it is defined. And the variable is only safe to use after the TDZ, so the temporal dead zone. All right, now what is actually the need for JavaScript to have a temporal dead zone? Well, the main reason that the TDZ was introduced in ES6 is that the behavior I described before makes it way easier to avoid and catch errors. Because using a variable that is set to undefined before it's actually declared can cause serious bugs which might be hard to find. And I will show you a small example in the next lecture. So accessing variables before declaration is bad practice and should be avoided. And the best way to avoid it is by simply getting an error when we attempt to do so. And that's exactly what the temporal dead zone does. A second and smaller reason why the TDZ exists is to make const variables actually work the way they are supposed to. So as you know, we can't reassign const variables, so it would not be possible to set them to undefined first and then assign their real value later. Const should never be reassigned, and so it's only assigned when execution actually reaches the declaration. And that makes it impossible to use the variable before. Okay? Make sense? Now, if hoisting creates so many problems, why does it exist in the first place? I get this question all the time, and so let's quickly talk about that here. So, the creator of JavaScript basically implemented hoisting so that we can use function declarations before we use them, because this is essential for some programming techniques, such as mutual recursion. Some people also think that it makes code a lot more readable. Now, the fact that it also works for var declarations is because that was the only way hoisting could be implemented at the time. So the hoisting of var variables is basically just a byproduct of hoisting functions. And it probably seemed like a good idea to simply set variables to undefined, which in hindsight is not really that great. But we need to remember that JavaScript was never intended to become the huge programming language that it is today. Also, we can't remove this feature from the language now, and so we just use let and const to work around this. All right, great. And with all that being said, let's now work on some practical hoisting examples. Maybe it didn't seem like it, but hoisting is actually a fairly straightforward process. So let's just go through the different scenarios here, starting with variables. So let's just create 3 variables here using the 3 different ways of declaring them. So now a let for the job, teacher, and then const for the birth year. Let's just call it year 1991. And now let's try to use all of these 3 variables before declaring them, just to see what happens. So me, job, and year. So from the rules that we learned in the previous lecture, what do you expect will happen now? Well, the first console.log results in undefined. And that's because variables declared with var are actually hoisted, but they are hoisted to the value of undefined. And so therefore, when we try to access them, undefined is exactly the result that we get. And so that's the reason why we see this here. Then on the contrary, we have this let variable. And so here we see that we cannot access job before initialization. And so that's exactly the kind of error that I showed you in the last slide. And the origin of this error is the fact that the job variable is still in the temporal dead zone here at this point, right? So remember that the temporal dead zone of a variable declared with let or const starts from the beginning of the current scope. And so that's basically here. So in this case, it's the global scope. So from the beginning of the scope until the point of the code where it is defined. And so here. And this means that at this point, of course, the job variable is still in the temporal dead zone. And the same is true for year. And so now we get the same error here for the year variable as well. All right. So let's comment out both of these. Let me just write here that this is hoisting with variables. And now let's try out functions. So let's create function declarations and function expressions here. So function, and again, I will use a simple add. And let me just call it add decl, which stands for declaration AB, and return A plus B. And now a function expression, so add expression and once more return A plus B. And now, since we're doing these two, let's also create an arrow. So add arrow AB and return A plus B implicitly. So I hope you remember that this is how the arrow function works. And now, once again, let's try to use these functions before they are defined. And so I will log them to the console, so the result of calling them, because they return something And so we need to log the result to the console. So as you already know. So let's add 2 plus 3. And now what do you think will happen? Do you think that it will be undefined again, just like we have here with the var variable? Let's see. And no, we actually get the result of 5. And so indeed, we were able to call the function declaration before it was actually defined here in the code. All right. And now let's try the same for the other two. Expression and add arrow. But now I hope that you can already anticipate what is going to happen. And so indeed, we get an cannot access add expression before initialization. And so that's exactly the same error that we got before here with this let and const variables. And that's because this function here right now is simply a const variable too. And so it means that it's now also in the temporal dead zone, right? So again, we are simply assigning a function value to this variable. And since this variable was defined with const, it is now in the temporal dead zone. And therefore we get this exact same error message as before. And the same, of course, is going to happen with the arrow, right? But now let me show you what happens when we change these to var. So do you think that now it will work somehow? Okay, we still get an error, but it is another error message here. So right now, add expression is not a function. And once again, the same is going to be happening for the arrow. Okay, and now let's think about the reason for this different error message here. So as you already know, any variables declared with var will be hoisted and set to undefined. And now this add expression here is essentially that. It's a variable declared with var, and so right now it is undefined. And then here we are trying to call undefined, basically. So we are doing essentially this. So undefined, and then we are trying to call it. And so we should now get the exact same error. So you see, it's not a function. And in fact, let me show it to you here even better. So add arrow should now be undefined. And indeed, here it is. And once more, that is because we now declared these two here with var. Okay, so let's simply take both of these out. And for you to keep this as a reference, I will leave this one as a var and this as a const. But just know that both of them will not work. The only function that you can use before declaring it is the function declaration. Okay, so now we covered all the rules here and saw how hoisting works. But now let's show me a very cool example which can demonstrate a pitfall of hoisting. And so it's a mistake that we can easily make if we're not careful and at the same time use var to declare our variables. So let's just write example here. So to start, let's declare a fictional function here. So a function which is a function declaration, and that's important. So a fictional function that will delete the shopping cart. So let's say that we have like an e-commerce website or application. So let's simply log here all products deleted. And so this is a dangerous function, okay, that we should not be calling without care. Next, let's also declare a variable which contains the number of products. And so now I will use a var, and this will then show you once more why we should not use var. Products equals 10. And now here at the top of our code, we are going to write some logic which will delete the shopping cart whenever the number of products is 0. Now we already know that 0 is a falsy value, and so we can write this, right? So in this case, we want to call delete shopping cart. All right. So again, here we have var num products set to 10. But then here we have this logic in which we want to write that when there is no products, we want to delete the shopping cart. But now what actually happens? So we get all products deleted, even though num products is actually 10. So why did that happen? Well, it is because of hoisting. So at this point of the code here, the num products variable is in fact not 10. Instead, what is it? Well, it is undefined. And that's because of the way hoisting works with var variables. So we just show that to you very quickly. And so indeed, now here from line 71, which is this one, we get this undefined. And we know that undefined is also a falsy value. And so therefore, this code will then still execute even though we thought that num products is 10. But in fact, it's undefined. And so that will also trigger the execution of this if block here. Now, of course, this is just a fictional, tiny example. But in a large code base with thousands of lines of code and without best practices, something like this can totally happen. And it's going to be a bug that will be hard to find. So what are these best practices? What is the conclusion of all this? Well, as a first step, as I told you many times, just don't use var to declare variables. Use const most of the time to declare variables, and let if you really need to change the variable later. Also, in order to write clean code, you should declare your variables at the top of each scope. That will just make your code at least look a little bit better. Finally, always declare all your functions first and use them only after the declaration. And this applies to all types of functions, even function declarations which are hoisted. So you could use function declarations before you declare them, but still, just don't do that. It's just not clean, okay? So what I just told you are the best practices, not the rules of how it works in JavaScript, all right? And now just to finish, since we're talking about the differences between let, const, and var here, let's just take 2 minutes to see yet another small difference between them. So let's again declare one variable for each. Let y equals 2. So the values don't matter at all here. And now let's just take a look at the window object in the console. Okay, x has been, of course, z here. And so let's now take a look here at the window object here in the console. And window is the global object of JavaScript in the browser. And you can see all kinds of stuff in here. For example, the alert window that we have used before, or also some other functions that we probably might have used already before. So I'm not going to go into that here. But what is important, so let's go all the way to the down here. And you can, of course, explore this by yourself in case you're interested in. But what matters here is that beside all these functions, we also get a property of x equals 1. And that's exactly the variable that we declared right here using the var keyword. However, we cannot find y or z here anywhere in this object. And that's because they were declared with let or const. And so variables declared that way do not create properties on the window object. So let me actually demonstrate this to you even better. So we can say, or we can test x equal window dot x. So here we are testing if x is actually a property of the window object. And so if it is, then of course x must be the same as window.x. And actually it is true. And now the same for y and z. And so in these cases, it is both false. So in conclusion, I just wanted to let you know that variables declared with var will create a property on the global window object. And that can have some implications in some cases. And again, you can take some time to explore the window object because it's quite interesting to see everything that is in there. All right, but with that being said, let's now finally move on to our next topic, which is going to be the this keyword. The this keyword is an extremely important concept to understand in JavaScript, and many beginners find it especially difficult. But don't worry, it's actually not that hard if you know exactly how the this keyword works. So the this keyword, or this variable, is basically a special variable that is created for every execution context, and therefore any function. In fact, we learned before that it's one of the three components of any execution context, along with the variable environment and scope chain that we already learned about before. Now, in general terms, the this keyword will always take the value of the owner of the function in which the this keyword is used. We also say that it points to the owner of that function. And that sounds very abstract, but we will see what that means in a second. For now, what's very important to understand is that the value of the this keyword is not static, so it's not always the same. It depends on how the function is actually called, and its value is only assigned when the function is actually called. So it's very different from a normal value in this regard. If we set, for example, x to 5, then x will always just be 5. But the this keyword, again, depends on the way in which a function is called. But what does that actually mean? Well, let's analyze 4 different ways in which functions can be called. And the first way to call a function is as a method, so as a function attached to an object. So when we call a method, the this keyword inside that method will simply point to the object on which the method is called. Or, in other words, it points to the object that is calling the method. Okay? And so let's illustrate this with a simple example. So the method here is the calc_h method, again, because it's a function attached to the Jonas object. In the last line here, we then call the method, and as you see, inside the method, we use the this keyword. Now, according to what we just learned, what should be the value of the this keyword here? And that's right, it should be Jonas, because that is the object that is calling the method down there in the last line, isn't it? And so then, on Jonas, we can of course access all the properties that it has, and so this.year will become 1989, because that's Jonas.year as well. So in this case, writing Jonas.year would have the exact same effect as this.year, but doing it this way is a way better solution, for many reasons that we will get into throughout the course. And we will play around with this example a bit more in the next video. But anyway, another way we call functions is by simply calling them as normal functions, so not as a method, and so not attached to any object. In this case, the this keyword will simply be undefined. However, that is only valid for strict mode. So if you're not in strict mode, this will actually point to the global object, which in case of the browser is the window object. And that can be very problematic, and so this is yet another very good reason to always use strict mode. Next, we have arrow functions. And while arrow functions are not exactly a way of calling functions, it's an important kind of function that we need to consider. Because remember, arrow functions do not get their own this keyword. Instead, if you use the this variable in an arrow function, it will simply be the this keyword of the surrounding function, so of the parent function. And in technical terms, this is called the lexical this keyword, because it simply gets picked up from the outer lexical scope of the arrow function. So never ever forget this very important property of arrow functions. Believe me that actually I run into 1 or 2 bugs because of this behavior. Okay, so it's really important not to forget that arrow functions do not get their own this keyword. Okay, and finally, if a function is called as an event listener, then the this keyword will always point to the DOM element that the handler function is attached to. Very straightforward, right? Now, the this keyword is usually a big source of confusion for beginners. But if you know these rules, then it should become a lot simpler. And to make it even simpler, it's also important to know what the this keyword is not. So this will never point to the function in which we are using it. Also, the this keyword will never point to the variable environment of the function. And these are 2 pretty common misconceptions, and so that's why I'm addressing them here. Okay? So again, the rules that I showed you here is all that you need to know. Alright, and now just for the sake of completion, there are actually other ways in which we can call a function. For example, using the new keyword or the call, apply, and bind methods. But we don't know yet what any of these are, and so I will talk about how the this keyword works with them when the time comes. Anyway, that's it for this lecture, so let's now use this in practice to make it crystal clear. Let's now see the rules of how the this keyword is defined in action. And let's start by taking a look at the this keyword outside of any function whatsoever. So just outside here in the global scope. And so we get that the this keyword in the global scope is simply the window object. So that's the global object that we just saw before, remember? And now let's do the same, but inside of just a regular function call. So we're going to use our old friend calc h here. So let's log to the console just the usual result so that we're actually doing something here. But then what we're really interested in is taking a look at this keyword. So let's now call this function. And so let's see. And now the result of taking a look, so at logging the this keyword, is undefined. Okay? And so what that means is that inside this just regular function call here, the this keyword will be undefined. And that's because we are in strict mode. Remember that in sloppy mode, it would be also the global object. So in this case, the window object. But you already know that you always should use strict mode. And so then in a regular function call like this, the this keyword will simply point to undefined. And with a regular function call, I simply mean a call of this function without the function being attached to any object. So without having an owner, so to say. But now let's see what happens if this function here was an arrow function. So let's just copy this. So calc h, both here and here, arrow. And let's call this one with a different value. And now think about the rules that we learned in the last video. So what do you think the this keyword will be if this function is an arrow function? And actually we still need to do that. So birth year. And so now it is a legit arrow function. And so once more, what do you think this keyword will now be? Think hard about it, and then let's check. And so it is window. So that's a little bit weird, maybe, right? So why is that? Why is the this keyword undefined in this function, but window in this function? Well, it is because the arrow function does not get its own this keyword. So instead, the arrow function simply uses the lexical this keyword, which means that it uses the this keyword of its parent function, or of its parent scope, so to say. And in this case, what is the lexical this keyword? So what is the this keyword in the parent scope of this function? Well, it is window, because window is the this keyword here in the global scope. So right here. Okay, that's why I started by showing you this one here. So in this case, this keyword here will simply point to the this keyword in the global scope. And so therefore, it will point to window. Unlike here in this normal function, which does actually get its own this keyword. It simply is undefined here, but it is its own this keyword. While this one here in the arrow function is actually not the this keyword of this function here. Okay, it is simply the this keyword of the parent scope. And that happens to be the window object in this case. In the next video, we will see some more real-world implications of the fact that the arrow function does not get its own this keyword. Now, next up, let's try to use the this keyword inside of a method. So let's quickly create a Jonas object here, just with a birth year, 1991, and then again our calc_age method. And so remember that this is basically now a function expression that we need to write here. And now let's log the this keyword here. And then let's call actually the calc_age function. For now, just to see what the this keyword will look like. And my hope is that you can guess already what it should look like. So let's save it to see the result. And indeed, it is the Jonas object. So exactly this object with calc_age and year. And so it means that's exactly this object. And that's exactly the rule that I told you in the previous lecture. So when we have a method call, the this keyword inside of the method will be the object that is calling the method. And in this case, that's the Jonas object. So Jonas here is basically the owner of the method. That's another way of saying it. And therefore, inside of calc_age, this is Jonas. And then we can use that to our advantage to calculate the age here based on the data that is already in this object. And so that's one of the big use cases for the this keyword. Right? Because then we don't have to pass in this data here again. So instead of having to do this again, we can simply use the birth year that is already in the object itself. And so we can use the this keyword to reference that object. And so this should now give us our usual value here of 46. Great. So that's pretty important stuff. And now let's move on just to one final example here in this lecture. So I keep saying that the this keyword will point to the object that is calling the method, right? And that means that the this keyword will not simply point at the object in which we wrote the method. So here we wrote the calc_age method inside of the Jonas object. And so we might think that that is the reason why the this keyword points to Jonas. But that is not true. The reason that the this keyword will point to Jonas in this case is because Jonas was the object calling that method. And that's a subtle but very important difference. And let me now show you why that is. So let's create a new object, which I'm going to call Matilda. And let's create a first name. Or actually, we don't need a name. Let's just say year 2017. And that's it. That's all we need in this object. Now, remember that a function is just a value, right? And therefore, we can do this. We can say Matilda.calcH should be equal to Jonas.calcH. So basically, here we simply copy the calcH method from Jonas to Matilda. And so now when we take a look at Matilda here, then we see that the calcH function is also in here. All right. And of course, it's still also in Jonas, but now we copied it from one object to the other. And this is called method borrowing. So we basically borrowed here the method from one object to the other, and so we don't have to write it in a duplicate way. So now let's say Matilda.calcH. And what do you think this keyword will look like now? And let's get rid of some of these before so that they don't clutter or output here. And you can then, of course, take them back if you want to see them in your own code. But now let me save this and see what the result of this calcH will be. So the H of Matilda gave us the correct result of 20, which is exactly 37 minus 27. And so this means that in this method call here, this keyword does now actually point to Matilda. And we can also see that here. So here, as we logged to this keyword, we see that it's actually the Matilda object because of this birth here. And so this proves exactly what I was just telling you before, which is the fact that the this keyword always points to the object that is calling the method. And so here we are calling the method on Matilda, right? And so therefore the this keyword will point to Matilda, which was the object which called the method. So even though the method is written here inside of the Jonas object, the this keyword will still point to Matilda if it is Matilda who calls the method. Okay? And so that's really important to understand. And it's the reason why I said in the last video that the this keyword is really dynamic. It's not static, and it depends on how the function is called. And we can take this even further by basically completely taking the function out of the Jonas object. So let's create just a variable called f for function, and then say jonas.calcH, and not call it, of course. So we just want to copy now the function into a new variable. And so once more, that is possible because a function is just a value. So we take this value here and copy it here. And of course, without calling it, okay? Just like here, where we copied the method from one place to the other, but we did not call it. So here we can take a look at f in the console. And so you will see that it's actually this function. But now, what implications is this going to have for the this keyword? Well, let's just try to call the f function, which remember is the code of jonas.calcH. And so now the this keyword should be undefined. And therefore we also get this error that it cannot read year of undefined. So that's coming from here because the this keyword is now undefined. And so undefined.year does of course not exist. So this happens because this f function here is now just a regular function call, right? It is not attached to any object. There is no owner of this f function anymore here at this point. And therefore, it is just a regular function call, just like here, for example. And so therefore, the this keyword is then also undefined, just like, again, here in this function, which was also a regular function call, just like our f function is now. All right, so again, that's a subtle difference in our code, but it makes all the difference in the result that we then get. And for sure, the this keyword is a subject that confuses many beginners in JavaScript. But hopefully this lecture and the previous one made it a little bit more clear. Now, we didn't talk about the event handler functions here that I also showed you in the last video, so on the slide there, but I'm leaving that for the advanced DOM section where we will come back to this. But for now, in the next video, we need to take an even more closer look at regular function versus arrow functions. Let me now show you some pitfalls of the this keyword related to regular functions and arrow functions. This way, we can learn when we should use and avoid each of them. And to start, let's get back the Jonas object from before. And I will also add a first name property. All right. And now let's add a second method here, but this time using an arrow function. So we will do a very simple greet method. And so an arrow function here, which simply logs to the console, hey, and then the name. And so we're going to take this name from the object. So this dot first name, or at least that's what we think we're doing. So let me now show you what happens as I call Jonas.greet. And maybe you can also anticipate it based on the knowledge that you already have of the this keyword when used in an arrow function. So let's see what the result is here. And we get hey undefined. So that's not hey Jonas as we might have expected. And the reason is exactly the one that I mentioned in the last lecture, which is the fact that an arrow function does not get its own this keyword. It will simply use the this keyword from its surroundings. So in other words, its parent's this keyword. And the parent scope of this greet method is the global scope. Okay. Just note here that this is actually not a code block. So you might think that like this kind of block here also creates its own scope, but it doesn't. So this is not a code block. It is an object literal. So it's just a way that we literally define objects. Okay. So all of this here is in the global scope still. And so therefore that includes this greet method. It is in the global scope. And so therefore the arrow function here, which does not have its own this keyword, will use the this keyword from the global scope. And remember, that is the window object, right? And so this dot first name is also undefined. And I think that this is actually something that we haven't seen before. So when we try to access a property that doesn't exist on a certain object, we do not get an error, but simply undefined. And so that is what is happening here. That's why we get undefined, because this is the window object. So just as we saw before, and then on the window object, there is no first name, and so we get undefined. Okay? And actually, this behavior can become pretty dangerous in case we use var to declare variables. Because remember from a previous lecture that variables declared with var actually create properties on the global object. And so let's imagine we have this. So var first name equals Matilda. And so now, as we run the greet function, it will say, hey Matilda. Okay, so why is that? So again, it is because inside of this function here, the this keyword is window. And actually, let me print that here to the console as well, just so we can really see that here happening. Okay, so again, window is the this keyword inside of this arrow function, even though that arrow function was called by the Jonas object. But that rule does not apply here because again, it's an arrow function. And so if we take a look at this window object now, and here close to F for first name, you see here that it does indeed have a property called first name with the value of Matilda. And again, that's because if we declare variables with var, that creates these kind of properties on the global object. And so therefore, this dot first name, which translates to window that first name, is then Matilda. And so that's why we then get hey Matilda here. So that's yet another reason not to use var. So you see there's a pretty long list against var. So from this example, the big takeaway is that as a best practice, you should never ever use an arrow function as a method. And in my opinion, that's even true if you're not even using the this keyword in a particular method. Because if you have this rule of never using an arrow function as a method, then you never have to think about which type of function you should use. You will always just use a normal function expression, and like this, you will then prevent this kind of mistakes from happen. So this mistake that we saw here with hey Matilda is easy to prevent by simply not using var. But even then, hey undefined is still a bug. It's still not correct. And so that would have easily been avoided by just using a regular function. Right? If we had this, then of course now this object Jonas, which is calling the function, would then be the this keyword. Right? So you see first name Jonas and then hey Jonas. Because now this method actually does get its own this keyword. But let's put it back. And okay. Great. And now one final example of a pitfall of the this keyword is when we have a function inside of a method. And that is a pretty common thing to happen. And so let's now take a look at an example of that. So let's create another Jonas object here. Or actually don't. Actually, let's just use this object here that we already have. And let's enhance this calc_h method. So what I want in here is a function that will basically return if the person is a millennial. So easy enough, let's create an isMillennial function in here. And let's simply log to the console if this dot year is greater or equal 1981, and so that's the same rule that we used before, so that the birth year needs to stay between 1981 and 1996. So below 1996. And then let's also call that function right here. So isMillennial will be called as we call the calc_h function. So let's also do that. So Jonas.calc_h. So we're calling this method here, the calc_h method, which is a regular method, so not an arrow function. And so therefore, the this keyword right here should be the Jonas object. But then in here we have a regular function, so this one, and here we are then calling it again. Now inside of this function, we are using the this keyword. And so let's now see what happens as we reload the page. And we get cannot read property year of undefined on line 138. So that's right here. So what this means is that the this keyword must be undefined. That's what it says here. So let's just log that as well. And here we can get rid of this one now. Okay. And indeed, the this keyword here is undefined. So why is that? Well, if we think about this, then this here is really just a regular function call, isn't it? It is a regular function call even though it happens inside of a method. And the rule says that inside a regular function call, which this clearly is, the this keyword must be undefined. And so therefore, it is undefined right here. So this is just as if this function was outside of this method. So if we copied this function out here, we would get the exact same result. Now, some people consider that this is a bug in JavaScript, but in my opinion, it's not really. It's just how the this keyword works. It's a clear rule that a regular function call has the this keyword set to undefined. And so that's just what is happening here. Now, there are two solutions to this problem. The first solution is to use an extra variable that we usually call self. So outside of the function, let's say self, and then we set that to this. Because here we are still outside of this isMillennial function. And so here we still have access to the this keyword set to Jonas, right? And so then in here, we can use simply self. And let's do that just here. And here I will duplicate this line so that we can keep the original one. And so now let's use self here. And so then through the scope chain, this self will be equal to this. So self is referenced here, but it's not, of course, in the scope. And so JavaScript goes up the scope chain into the parent scope, which is calc_h. And so here is where self is defined, and it is defined as this. So as the this keyword. And so this is a way in which we can preserve the this keyword. This can also be called that, so that you might also see. And so as we reload now, this actually works. So now we get the value of true. So this was kind of the pre-ES6 solution, but you might still find this solution in some older code bases. However, now in ES6, we have a more modern and better solution. And that solution is to use an arrow function. All right. So let's actually copy all of this because I want to preserve both versions here. And now I will just comment out this first. Let's say solution 1. But now here we have solution 2, which does not need this extra variable. Okay, so let's get rid of this, bring this back, and here, this again. And now, again, the solution to the problem that we saw before is that we can now use an arrow function. And that is going to work because the arrow function does not have its own this keyword. Right? So let's remember again that when we just call this, we get that the this keyword is undefined. And that's because a regular function gets its own this keyword. But the arrow function will not. It will simply use the this keyword of its parent scope. And in this case, that will be the calc_h method. And in here, the this keyword is Jonas, so the Jonas object. And therefore, then, here in an arrow function, that would also be the this keyword. And then it is going to work as expected. And indeed, now it is true. And again, this worked because this arrow function uses the this keyword from its parent scope. And in this case, in the parent scope, the this keyword is Jonas. So basically, an arrow function inherits the this keyword from the parent scope. And that is exactly what we need here. All right. And so here you see that it's pretty important to know exactly how each of the different type of functions work in regard to the this keyword, because then you can really use them according to your specific needs. Great. So I hope that especially this solution here made sense to you, and that when you need it at some point in your journey or in your job, you can remember that this is a very useful use case of the arrow function. Now, just to finish this lecture, I also want to quickly touch on the arguments keyword. Maybe you remember me talking about that also in a previous lecture. So in the video about execution contexts and the call stack, we learned that functions also get access to an arguments keyword. So not just the this keyword, but also an arguments keyword. Now, just like the this keyword, the arguments keyword is only available in regular functions. So let's create another function here. So first an expression. So again, basically that's our functions for adding. And actually, let me just grab them from here. I think I defined them somewhere up here. Yes. So there's no need to rewrite the same code over and over again. You just add a comment here, arguments, key, word. And then let me also print to the console that keyword. So let me quickly call this function here now. So 2 and 5. So just so we see the arguments keyword. And so down here it is. And you see that we get basically an array with 2 and 5. And so that's exactly the two parameters that we passed in. And this can be useful when we need a function to accept more parameters than we actually specified. So this is something that we never did before. So up until this point, we have only ever specified exactly the arguments that we have here in the list of parameters. So we have 2 parameters and so 2 arguments. But it is completely legal to add more arguments. They will not have a name, so we didn't name them, but they exist. And we can see them here in the arguments array. All right, so they do appear here and we can use them therefore in the functions. For example, we could use a loop and then loop over this array and add all the numbers together. But now my point here is that the arrow function does not get this keyword. So let's also log it to the console here. So let's put this here in curly braces. Then remember, when we have more than one line of code, we need to explicitly return. And so let's try to take a look at the arguments keyword here as well. So add arrow 2, 5, 8, let's say. But then we get an error. So arguments is not defined. All right. So this was simply just to show you that the arguments keyword exists, but that it only exists in regular functions. So in function expressions like this, but also in function declarations, but not in an arrow function. But anyway, the arguments keyword is not that important in modern JavaScript anymore, because now we have a more modern way of dealing with multiple parameters. But still, it's important that you are aware that this arguments keyword exists. All right. And now with all these lectures on regular functions and arrow functions, you should know all the differences between them and, even more importantly, when to use each of them. As we move towards the end of this section, we need to learn about the big difference between the way primitive types and objects are stored in memory. And this is actually a very practical aspect and one that causes a lot of confusion in beginners. So let's actually start by writing some code this time to understand what the confusion actually is, so that I can then show you how it all works behind the scenes. So right now, I'm not going to explain how the code we will write now works, but I will just show you what the source of confusion is. But for now, let's start with a simple example with primitives. And so remember, primitives are like numbers, strings, booleans, etc. So simply setting the age to 30. And then I'm creating a old age variable. And this one I will set to the age, because now it is my birthday basically. And so my age changes to 31. But I still wanted to preserve my old age here in this variable. Okay, so let's log the results to the console now. And they should be pretty much what we expect at this point. So you see that my current age is 31 because, well, I changed the original one from 30 to 31. But the old age is still 30 here. And that's because I set it here at this point of the code to age, which was still 30 at this point. And so then changing the age here from 30 to 31 did of course not affect the old age variable. Again, because at this point here, age was still 30. All right. So here, hopefully there is not much confusion. Everything works just as expected. But now let's create another scenario which has an object. So I'm simply going to create an object for me with the name of Jonas and age 30. And now let's copy this object, because let's say that I have a friend who's also called Jonas. And so instead of creating a brand new object from scratch, I will just copy the me object. So const friend equals me. Okay? And so now both the name and the age are the same, but let's say that we have different ages. And so let's change the age of my friend. And that's pretty straightforward, right? So let's say that he is 27 years old. But of course, we did not change me.age, right? So let's now take a look at both of them in the console. So first my friend. So that's the friend object. And then also me. Or we could say Jonas, it doesn't really matter. But what matters is that we will see the me object. And what do we think will happen now? So let me show it to you. And now we get that both me and my friend have the age of 27. And that looks a little bit strange, because all we did was to change the age of the friend, right? Nowhere here I have me.age equals 27. But still, for myself, so here at the me object, the age is also 27. And so that is what I mean by source of confusion. And so in this video, let's now find out why it works this way. Now, before we can understand the code that we just wrote, we need to review some basics here. First, we need to remember about JavaScript's primitive data types, which are number, string, boolean, undefined, null, symbol, and big int. Then everything else are basically objects. So objects created with the object literal, arrays, and even functions are all objects. Now, when we're talking about memory and memory management, it's usual to call primitives primitive types and objects reference types because of the different way in which they are stored in memory. Next, we need to remember about the JavaScript engine. So the engine has two components, the call stack where functions are executed and the heap where objects are stored in memory. And that's right, all our objects, or in other words, reference types, will get stored right in the memory heap. And I mentioned that when we first talked about the engine, but now you will finally learn how that actually works. On the other hand, primitives, or primitive types, are stored in the call stack. And with that, I mean that primitive types are stored in the execution contexts in which they are declared. But for the sake of simplicity, let's ignore that detail now and simply say that primitive types are stored in the call stack, because that's where execution contexts run. All right, but now how does all that actually work? And why did our code example earlier behave in that weird way? Well, let's find out. So here we have the two code examples from earlier, as well as the engine with call stack and heap. And let's start by looking at the primitive values example. So when we declare a variable like age equals 30, what actually happens inside the JavaScript engine and the computer's memory? Well, first, JavaScript will create a so-called unique identifier with the variable name. Then a piece of memory will be allocated with a certain address, so 0001 in this example, and finally the value will be stored in memory at the specified address. So in this case, the value 30 will be specified at memory address 0001. And remember, this all happens in the call stack where primitive values are stored. Now, what's extremely important to understand here is that the identifier actually points to the address and not to the value itself. So we would say that the age variable is equal to 30, but in fact, age is equal to the memory address 0001, which holds the value of 30. All right? And this subtle distinction is very important to keep in mind. Now, in the next line, we declare old age to be equal to age. So, knowing that a variable actually holds a memory address, what should old age look like? Well, it will simply point to the same memory address as the age variable. And so, it will look like old age is simply 30 as well. Great, but now in the next line, we set age to 31. So what will happen then? The value at address 0001 will certainly not become 31, because that would change old age as well, since they both point to the same address. So that would make no sense at all. Also, the value at a certain memory address is immutable, or in other words, it cannot be changed. So instead, what's going to happen here is that a new piece of memory is allocated, so is created, and the age identifier now simply points to the new address, which is holding the new value of 31. All right, and that's why when we lock both our variables to the console in the end, they both return exactly the values that we expect. Now with reference values, things work a bit differently, which is the reason why this example gave us that unexpected weird behavior earlier in practice. So what's the origin of this weird, unexpected result? Well, when a new object is created, such as this me object, it is stored in the heap. And such as before, there is a memory address and then the value itself. Now, in the case of reference values like this me object, the me identifier does actually not point directly to this newly created memory address in the heap. So in this example, D30F. Instead, it will point to a new piece of memory that's created in the stack. And this new piece of memory will then point to the object that's in the heap by using the memory address as its value. In other words, the piece of memory in the call stack has a reference to the piece of memory in the heap which holds our me object. Okay? And that's the reason why we call objects reference types in this context. So again, when we declare a variable as an object, an identifier is created which points to a piece of memory in the stack, which in turn points to a piece of memory in the heap. And that is where the object is actually stored. And it works this way because objects might be too large to be stored in the stack. Instead, they are stored in the heap, which is like an almost unlimited memory pool. And the stack just keeps a reference to where the object is actually stored in the heap so that it can find it whenever necessary. Now, moving on in the code, we create a new variable called friend that we set equal to the me object. So what will happen here? Well, just like with primitive values, the friend identifier will point to the exact same memory address as the me identifier. And again, that address contains the reference which then points to the object itself. And like this, the friend object is now essentially the exact same as the me object. Do you see that here in the diagram? So here comes the interesting part, because now we're actually going to change a property in the friend object by setting friend.age to 27. So what happens then is that the object is found in the heap and the 30 is changed to 27. Great. And by the way, even though we defined the friend variable as a constant, we can actually still manipulate the object without problems. And when we think about that, it makes sense, because we're actually not changing the value in memory for the friend identifier. It is still D305, so the reference to the object. All we did was to change the value in the heap, and that's not a problem. So it's a misconception that all variables declared with const are immutable. In fact, that is only true for primitive values, but not for reference values. So keep that in mind whenever you're working with const. Anyway, as we log the friend variable to the console, we get the age of 27, just as we said it before. But then, when we log the me object, we get that weird behavior that we could previously not explain and not understand. But with everything that we learned in this lecture, it actually now makes sense that in the me object, age is now also 27, even though we never changed me.age directly. And the reason for this, as we can see in this slide, is the fact that me and friend actually point to the exact same object in the memory heap. So whenever we change something in this object, it will always be reflected in friend and in me. So in both these objects. So these are basically just two different identifiers pointing to the exact same value. And once again, that value is the memory address D305, which points to the reference in the memory heap. And one important implication of this is that whenever you think that you're copying an object, you're really just creating a new variable that points to the exact same object. And this has huge implications for the way JavaScript works in practice, and we will see that in the next video and throughout the course. Now, there are actually ways around this, as we will also learn later, but in general, this is how reference values work in JavaScript. So make sure to really understand this, as well as the implications that this behavior has, even if that means that you have to rewatch this lecture, or at least the explanation of this slide. All right? Then, once you really understand what happened here in this example, let's understand primitive values and reference values even better in practice in the next lecture. But before we do that, let me just quickly take a second and mention 3 more really big topics about how JavaScript works behind the scenes that will not be in this section, but closer to where we actually need to learn about them. For example, one fundamental concept of JavaScript is prototypal inheritance, but we will only talk about that in the object-oriented programming section of this course, because it doesn't make sense to learn about this now, only to then forget it all until we finally reach that section. The same is true for a detailed lecture on the event loop. So I already introduced the event loop in this section, but in the section about asynchronous JavaScript, we will dive really deep into how exactly the event loop works and why it's such a fundamental piece of the JavaScript engine. Finally, we will have lectures on how the DOM actually works behind the scenes too. And that's going to be in the advanced DOM and events section, so that you can then apply what you learned there right away. Okay? And with that being said, let's now move on. Let's now create a similar example to what we had in the last video, just so that we can actually see this happening in practice. And just like in the last video, let's start by mutating a primitive value. So let's now use the last name. And I'm going to set it here to Williams. And so that's the initial value of this last name. Then let's also copy it. And so that's because, let's say that this person gets married and decides to change their last name. However, we still want to remember the old name. And so we say old last name is equal to the current last name at this position of the code. But then we mutate actually the last name to Davis. So basically when this person gets married, they then change their last name to Davis. And of course, if we now check out both of them, so first the last name and then the old last name, then we see that they are in fact different. So Davis is the new last name, so the one that we mutated here, and Williams is this old last name that was copied right here in this first line of code, or actually the second line of code. So here everything works as we would expect in an intuitive way. Now remember that it works this way because each primitive value will simply be saved into its own piece of memory in the stack. Okay? But now let's do the same thing with an object, which, as we already know, is a reference value because it is going to be stored in the heap, and the stack then just keeps a reference to the memory position at which the object is stored in the heap. So let's create an object called Jessica. And so here we will have a first name of Jessica and a last name of Williams. Let's also give her an age of 27, just to make it more complete. And now let's again say that Jessica will get married and will therefore change her last name. And so this time, let's create a new object for the married Jessica. So married Jessica, and it should be equal to Jessica. So we're copying the entire object here. At least that's what it looks like. But behind the scenes, we are actually just copying the reference, which will then point to the same object. Remember that? And so now as we change the last name on married Jessica, so last name, let's change that to Davis. But as we already know, this will not give us the result that we expect. So before marriage, let's log this original Jessica object, so to say. And then after marriage, and then here the married Jessica object, giving it a save. And now as we see, we get before the marriage and after the marriage both the last name of Davis. All right, so the last name Davis is now also in the original Jessica object and not just in the one that we copied. And now at this point, we already know why this happened. So just to remember that, it happened because when we attempted to copy the original Jessica object, it did in fact not create a new object in the heap. So this one, again, is not a new object in the heap. It's simply just another variable in the stack which holds the reference to the original object. So both of these two variables simply point to exactly the same memory address in the heap. And that's because in the stack, they both hold the same memory address reference. And so of course, it makes sense that if we change a property on married Jessica, it will also change on Jessica itself. So again, because they are essentially just two different names for the same thing. Now, this is also the reason why we can change properties in the married Jessica object, which was declared using a const here. And const is supposed to be for constants, so for things that we cannot change. However, what actually needs to be constant is the value in the stack. And in the stack, the value only holds the reference, which we are not actually changing. The only thing that we are changing is the underlying object that is stored in the heap. And that is okay to change. That has nothing to do with const or let. Alright? That's only about the value in the stack. But if we change something in the heap, that has nothing to do with const or let. Now what we can't do is to assign a completely different object now to Mary Jessica. So for example, we could not say Mary Jessica is equal to this new empty object. So that will not work, because this new object will be stored at a different position in memory, and therefore the reference to that position in memory will have to change here in this variable. And therefore that does not work, because that is in the stack, and so since it is a constant, we cannot change that value in the stack. So we cannot change the value to a new memory address, and therefore this does not work. If it was a let here, then we could do this, what we have here. But since it's a constant, again, it is not allowed. So as a conclusion, completely changing the object, so assigning a new object to it, is completely different than simply changing a property as we did here. Okay? So it's a fundamental difference, so please make sure to really understand this. Anyway, what if we actually really wanted to copy the object so that we could then change one of them without changing the other? So let me show you a way in which we can do that. Let's first add some comments here once more. So primitive types, reference types, and then let's now say copying objects. All right. And actually, let's create a new Jessica object. Let me, in fact, copy it from here. So let's say Jessica 2. And so now, if we really wanted to copy this object, we could use a function called object.assign. And what this function does is to essentially merge two objects and then return a new one. So we could do this, object.assign, and then again we can use this function to merge two objects. And so what we can do is to simply merge an empty new object with Jessica 2. And this will then create a completely new object where all the properties are really copied. All right, so the result of calling this function here with these arguments will be a new object. And so let's store that in Jessica copy. And now let's say that Jessica copy gets married. So the same situation as before, changing her last name to Davis. And now let's log both to the console just like here. So Jessica 2. And then here it's Jessica copy. So let's see what happens now. And so it's these last two here from line 222 and 223, right? And so now indeed we can preserve the original last name Williams after we change the last name on this other object here. So this Jessica copy. And what this means is that this object now is indeed a real copy of the original. So all the properties were essentially copied from one object to the other. And so behind the scenes, what that means is that a new object was in fact created in the heap, and Jessica copy is now pointing to that object. So it has a reference to that new object. However, there is still a problem, because using this technique of object.assign only works on the first level. Or in other words, if we have an object inside the object, then this inner object will actually still be the same. So it will still point to the same place in memory. And that's why we say that this object.assign only creates a shallow copy and not a deep clone, which is what we would like to have. So again, a shallow copy will only copy the properties in the first level, while a deep clone would copy everything. And to illustrate this, let me actually show you what I mean. And so let's add an array here in this original object. So an array of family. And this is going to work as an example because an array is really just an object behind the scenes. So here I can prove my point to you with this. So we have now an array called family, okay? And so you see that now this array here is indeed in both objects. So, okay, so far so good. But now let's actually change that array in Jessica copy. So in this one, because as Jessica married, she also increased her family. And so let's now add some more family members there. So Jessica copy dot family, and then let's use the push method to add a new element to the end of the array. And let's add Mary, and let's also add another one. So family dot push, and let's add John. So remember, here we are manipulating the copied object, which is actually a copy, but now here we are manipulating an object that's within the object. So that's this object. And so now as we save this, it still looks the same, but that's because we need to log, of course, after this operation happens. And so now we see that both the objects now have a family with 4 members. Let's open this a little bit, give it some more space. And so indeed, now before the marriage and after a marriage, the family has all these 4 members. All right. So the last name was, of course, as we already saw, preserved. So the name before the marriage is Williams, and that was preserved because that's in the first level, and object.assign here took care of copying that property. And so that was not changed as we changed the last name in the copy. However, the family object is a deeply nested object. And so therefore, object.assign did not really, behind the scenes, copy it to the new object. All right. So in essence, both the objects Jessica2 and Jessica copy have a property called family, which points at the same object in the memory heap. And that object is, of course, this array. And so when we change the array in one of them, it's also going to be changed in the other one. Now, a deep clone is what we would need here, but it is not easy to achieve. And it would actually be beyond the scope of this video to learn how to create a deep clone. Usually we do something like this, which is like really complex, using an external library, for example, like Lodash. And this library has a ton of helpful tools, and one of them is for deep cloning. And actually we will do that in a later section, just so you see how we can include an external library to do this kind of stuff. All right, and with this, we actually finish this section about how JavaScript works behind the scenes. And it was a long one with so many things and so many new concepts to learn. And many of them were hard and probably confusing, but that's not a problem. So it's always a part of learning. And even if you did not understand 100% of everything, you're still good to move on in the course to the next section now. But just reaching the end of this section already gave you a big advantage over many other developers which have no idea about many of the things that I showed you here in this section. So congratulations for sticking with it to the end and for learning all of this valuable knowledge. And now I see you in the next section.